Great, thank you. Okay, so ang di-discuss natin ngayong araw ay experiment 1. Okay, it's good na lahat kayo ay natapos. And buti na lang at na-overcome natin yung ating issues regarding sa internet at yung kabagalan ng MATLAB. Okay, tawag dito, may iba kayong related na concerns tungkol dito, tungkol dun sa paggamit ng MATLAB or dun sa kung paano nyo ginawa yung experiment 1 na gusto nyo bring up? Wala, so...
Sir?
Yes, of course.
Sir, pwedeng pa-discuss po ng types po ng solver.
Nung alin?
Yung solver po.
I-discuss natin yun.
Thank you, sir.
Meron pa bang iba? Okay, so simulan na natin to. And first of all, almost perfect yung inyong submission except for this small thing, which is yung root mean square. Okay, ang root mean square ay basically the square root of the mean or average of the squares of the individual points. So ganyan siya kino-compute. Nag-share ako sa inyo nung live script kung paano siya sinosolve. Okay. And kung titignan ninyo, actually nandito naman, kung titignan ninyo, first, ang ginagawa nyo dito ay kinukuha nyo muna yung square ng individual na points. Okay, pagkatapos kinukuha nyo yung average ng squares na yon. So when you take the average, of course itong y-square na to array yan. Pero when you take the average, that means na single value na to. So hindi na siya array. Then if you take the square root of the average, yun na yung inyong RMS. Okay? Now, bakit tawag dito, bakit in-insist ko na RMS yung kukunin nyo? Kasi RMS is the only tawag dito, parameter that you can measure with the voltmeter. If you don't have an oscilloscope kasi hindi naman yan readily available, it's bulky. Okay, the measuring instrument that you can easily use is of course a voltmeter or an ammeter. Okay, and the ammeter or voltmeter measures para always yung root mean square. Okay, that's why dun sa instructions, nung sinabi ko na maglagay kayo ng 12 volts RMS, it's not a trick question, but it's a practical question, okay, or a practical instruction. Because everything that is stated, pag nag-uusap kayo with other, tawag dito, electricians or other electrical engineer, yung ganun, parati nilang binabanggit yung RMS na voltage. Okay? Okay, kasi yun yung measurable na quantity, immediately measurable na quantity. Okay? So, ito lang yung naging mistake ninyo dun sa number 1, na sa exercise number 1. Experiment number 1. So, other than that, nagawa nyo naman ng maayos yung inyong circuit. Okay? Now, let's go to the solver. Okay? Ang solver, ganito yun. So basically, diyan yung MATLAB, and then meron tayong, within the MATLAB, meron Simulink. Now yung Simulink, tawag dito, lahat naman kayo nag-undergo nung Simulink on-ramp. And with the Simulink on-ramp, you can actually, tawag dito, model a differential equation. Okay, and then solve the differential equation by means of blocks, right? Of course, kung nung ginawa niyo yung Simulink na on-ramp, parang hindi siya ganun ka-practical. That's why MATLAB thought of doing Simscape. Sa Simscape, especially or particularly sa electrical circuits, nandiyan dyan na yung mga blocks for resistors, for capacitors. So that one is a bit more practical, di ba? So you don't have to look at the differential equation, or you don't need to know actually yung differential equation in order to solve yung electrical circuit. So all you need to do is to build the electrical circuit, and then you just let MATLAB do the work. But here's how MATLAB solves it kasi. So the electrical circuit is there, and then based on your connections, ang gagawin ng MATLAB is if you figure out niya yung Simulink equivalent nung electrical circuit. And yung Simulink equivalent na yon is in the form of a differential equation. So the circuit that you build sa Simscape is solved by using a differential equation that MATLAB tries to estimate. Okay, now there are many ways to solve yung differential equation, and yun yung mga iba't ibang solvers na present. Okay, so naglagay ako dito ng link. So when I send you this slides, naglagay ako dito ng link that you can click. Okay, para malaman kung ano yung iba-ibang MATLAB solvers, at naglagay din ako ng link dito para maintindihan nyo kung anong ibig sabihin ng fixed step at saka variable step. Okay, so now let's take a look at yung links na yon. Okay, briefly. Okay, so first, tignan muna natin yung fixed versus variable solver. Okay, so ganito lang yung difference dyan. So ito yung i-highlight ko. Okay, hindi ko alam kung nababasa ninyo. Let's see if I can zoom this in a bit further. Okay, basically ganito lang yan. Ang difference between a fixed solver at saka variable step solver. Sa fixed step, ibig sabihin yung points, yung intervals ninyo is equally spaced. Pero sa variable step, yung intervals ninyo ay hindi yan equally spaced. Okay? Sa fixed step, yan yung parating yung ginagawa dun sa tawag dito, sa computational physics ninyo, di ba? For example, yung time, sinaset nyo as 0.1 na time interval. Okay, yan ang fixed step. Nung ginawa ninyo yung ODE dun sa machine problem ninyo, fixed step parati yung ginagawa nyo dyan. But sometimes, yung fixed step solver na yan is inefficient. Okay, bakit? Kasi magde-depend yan dun sa kung ano yung shape kasi nung solution. So kung linear lang siya, straight line siya, okay lang ang fixed step. Pero kung meron mga sudden changes, like for example, Dirac delta, mamimiss mo yung part na yon dun sa peak na yon, okay, if you use a fixed step solver. Okay? Kung hindi tama yung step size mo. So the solution for that is to use a variable step solver. So in variable step solving, hindi na nagmamatter, or MATLAB na ang mag-figure out nung kung ano yung interval na gagamitin niya. Okay, and he tries to figure it out by taking a look at yung pattern previous dun sa step na pinag-aaral na sinosolve niya, and then yung next step din. Tinitignan niya kung biglang mag-change ba o hindi, and then yung software re-evaluates kung ano yung step size, optimal step size na gagamitin niya. So yun yung difference between this fixed step at saka variable step. It's of course safer to use a variable step solver if you're not really sure kung ano yung shape nung inyong solution. Okay? So you just use a variable step solver and then let MATLAB do the work. Okay? Now, what about yung ODE solver? Okay. So napansin nyo maraming iba-ibang solvers. Okay, so merong ODE 15S, ODE 15, ODE 23. Okay, so nagde-depend yan actually dun sa tawag dito, algorithm na develop. Okay, so bawat isa sa mga solver yan ay dinevelop ng mga software engineers nila sa MATLAB. Okay, so you can see yung mga solvers dito. Okay, and kung anong ibig sabihin kung anong implication ng solver. Okay, so ODE 45, ODE 23, 113, and so on and so forth. And then you can take a look at yung iba't ibang solvers and then yung problem type, kung stiff or non-stiff. Meron akong video na nilagay dun sa slide. May link akong nilagay dun sa slide, okay, na makikita nyo rito regarding dun sa description ng stiffness ng isang ordinary differential equation. Basically, it just tells you kung ano yung kung gaano ka sharp yung changes dun sa differential equation nyo, sa solution dun sa differential equation. So if it's a sudden change or merong mga sudden changes dun sa solution sa differential equation, then it's a stiff problem, okay, or stiff ordinary differential equation. Okay? Pero kung smoothly varying lang siya like a sinusoidal function, then it's a non-stiff ODE. Now, if you don't know kung anong klaseng solution ang ina-expect ninyo, then you can always start with ODE 45. Okay? ODE 45 is for a non-stiff, medium accuracy, okay, na solver. Okay, most of the ayan, nakalagay naman dito, most of the time ODE 45 should be the first solver that you try. Okay? So next, kung mag-fail yan, ODE 23, and then you try nyo tong ang problema lang sa ODE 23 is low accuracy. Okay, but it is more efficient than ODE 45. Okay, and the reason kung bakit low yung accuracy niya dahil mababa yung tolerance na ginagamit dito. At saka moderate yung stiffness nung paraan niya ng pag-solve. Okay? So ganun. So it's actually these things are not physics, it's more of a software or computational tawag dito thing. So yun nga, ang technique is you solve the problem using ODE 45 first, and then sometimes MATLAB will tell you naman kung ano yung isa-suggest niya na magandang gamitin na solver. Okay? So yan yung para sa solver. I hope nasagot ko yung tanong niyo regarding that. Okay, and I understand na nung pinapanood ko yung videos ng iba na hinuhulaan niyo lang kung ano yung nangyayari. Okay, kung anong solver yung ginagamit niyo. Okay, so it's fine. Okay, but always remember na mayroong mga resources for all of these. And alam niyo naman na MATLAB has numerous resources. Kung hindi niyo makikita dun sa help, makikita niyo yan sa internet. Okay. Okay. So next, sometimes there's more than one correct solver. Okay, pero again, MATLAB recommends the best solver. So if you use a solver and nagka-problema doon sa solver na yan, MATLAB will tell you kung ano yung best solver na gagamitin. Okay, you can see the current solver in the lower right corner dun sa screen. Okay, alam siguro ng iba yon. So if we go to MATLAB, okay, and if we go to this simple circuit, okay, lagyan natin itong load voltage at source current. Okay, the solver can be found here. Oops. Okay, andi dito. Sa baba, lower right. Okay? Diyan, sa lower right. Nakikita nyo ba yung binibilugan ko? Or hina-highlight? Okay, so pwede pa nga pala ako mag-annotate. Okay, so nandito. Yan. Diyan sa lower right. Okay? So, pwede nyo i-click yan, of course. Okay, and pwede nyo ng diretso na dyan na puntahan yung settings. Okay. So makikita nyo na mabagal din sa akin. Okay, and then you can change the settings from here. Okay, so variable step, tulad na sinabi ko sa inyo, and here it's ODE 23, okay? Okay, so ngayon, ang gagawin natin is ilalagay ko rito, discrete, okay, and okay, let's see what happens. Apply, then okay, and then i-run natin yan. So makikita nyo rito na variable step discrete dahil yun yung last na pinili natin. Okay. Yes, and then of course, merong error, okay? Can be solved to use, okay, so yan. So meron na siyang recommendation regarding that. Okay, and if we change this to another type of solver, okay, like for example, ODE 45, apply. Okay, and then we run it. Okay, yan. Ito yung sinasabi ko na, oops, saan yan? Hindi pa tapos yung, okay, so tapos na siya. Okay, so with ODE 45, ito yung naging result. So makikita nyo na sobrang discrete yung tawag dito. Sinusoidal solution. And meron din siya suggestion dito. Choose an implicit solver which is ODE 23. Then may ibang pa siyang suggestions dito. So kung ayaw nyo mag-isip, it's not a problem. Click nyo lang yung fix. Okay, automatically pinapalitan niya dito ODE 23. Okay, pwede na natin itong i-close. Oops. And then pag nirun natin ito, of course makikita natin yung mas malinis na solution. Okay. Okay, so yun yung para sa solver. Okay, next, stop time. Okay, so may mga iba ako nakita na nagka-problema rin dito sa pag-guess ng stop time. Okay, yung stop time determines kung ano yung length of time na i-display nyo basically sa graph. Okay, so anong tawag dito? Sige, balik tayo sa MATLAB. So here, ang stop time is 0.1. So kung makikita nyo sa graph, it's from 0 to 0.1. Okay, 0 to 0.1. Ganun din dito sa load voltage. 0 to 0.1. Now, if you use a stop time na 10 seconds or 1 second, may imagine nyo kung gaano ka wavy or gaano ka squeezed yung mga ano na yan, yung waveform na yan. Okay, now you don't have to guess yung stop time kasi yung stop time is dependent on the frequency. Okay, now ang sinabi kong frequency is 60 Hz, which means na isang period is 1/60 or 0.0167 seconds. So if you use a stop time of 10 seconds, ilang cycles yon, di ba? But if you use a set a stop time of, for example, 0.05 seconds, then you expect 3 cycles, okay, or three periods. Okay, so what happens when stop time increases to 10 seconds? Okay, may mga iba ako nakita na ganun yung naging problema. So if you go here, so if here I chose a stop time of 0.1 seconds, so ibig sabihin 6 cycles yan. Kung bibilangin ninyo, it's 1, 2, 3, 4, 5, 6 cycles. Diba? 1, 2, 3, 4, 5, 6 cycles. Okay. Okay, and if you choose 10 seconds, okay, dito. Okay. Then we run it. Okay, so ganyan yung kinalabasan. Okay. So hindi na, well, in this case, hindi lumabas yung hindi lumabas yung solution. Bakit? Kasi ang ginamit natin dito is variable fixed or variable solver using ODE23. So if you want to see the wave pattern, papalitan nyo tong ODE23 na solver at papalitan nyo rin yung tawag dito, interval dun sa variable step size. Okay, kasi titignan nyo ilang data points lang yung nilagay niya, di ba? So hindi talaga pasok yung waveform dito. Okay, so sa variable solver details, so nandyan. Okay, and then sige. Yan na muna natin. Then hindi naman nag-make sense na trabahuhin yan. 0. So yung iba sa inyo, ang ginawa is 1/60 yung ginamit. Okay? Which is actually a good idea. So if you want 3 cycles, you use 3/60. Diba? So yun yung ginawa ng isang grupo. Okay, so makikita nyo yun dito. So 1, 2, and then 3 cycles corresponding to tawag dito. Ayan, well, 3 cycles. Okay? So yun yung yun yung para dito sa stop time. Okay? Okay, then next, okay, yung figure menu bar. So let's go back here and tignan natin yung figure menu bar. So marami kayong pwede actually gawin dito. Okay, and one thing that you can help me with, okay, ito okay na yan, it's fine. Pero one thing that you can help me with is if you go to settings, okay, and pumunta kayo dito, kita niyo yan, open at simulation start, you click that, you use a check mark there. Ang gagawin niyo dyan is when this runs and it finishes, lalabas na kagad yung itong image, okay, yung solution. So pag hindi yan nakaklik, so for example here, okay, tatanggalin ko yung pag-click dito, okay. Okay. So close ko to. Close ko yan and then I run this. Ay. Okay, so mukhang naka-open yun. Okay, naka-open na siya. Open at simulation start. Anyway, if I don't click this, ang mangyayari lang is when I run this, ito lang yung lilitaw. Okay, automatic siyang lilitaw after the program finishes executing. Okay, and that's something you can help me with when you do your next circuits para hindi ko na i-click yung voltmeters na ito at saka itong ammeter. Okay, what else can you do here? Okay, yung input port is just single port kasi yung ginagamit nyo ritong block, you're just using a single port here. Okay, tapos, yeah, okay, pwede na yan. Okay na yan. So just leave everything as is. Now, if you want to get your data, so pwede nyong i-click to. Log data to workspace. And then, lagay kayo dyan ng name. Okay, any name will be fine. So data set, yan, lagay dyan. Okay, so i-click nyo yan kung gusto nyo ma-generate yung data. Okay, then click OK. Okay, so gagawin natin for both X and Y. So Y is the current and X is the voltage. Okay, so go to logging and then i-click nyo yan, lagyan nyo ng check mark yan. Okay, so that should be fine. Okay, so ang gawin ko muna is i-clear ko muna itong workspace. So clear the workspace. Okay, and then i-run natin itong program. Okay. Okay, so nakita nyo hindi lumitaw yung result ng voltmeter kasi in-click ko yung open at simulation start. Okay, so lalagay ko na yan dyan ngayon. Okay, now makikita nyo sa workspace meron itong variable. Okay. Move ko lang ito ng konti. Okay, so ito yung output variable from the result. If you double click that, okay, so ito yung ginawa ninyo, scope data. Yan yung name na nilagay natin kanina, scope data. Scope data 1 is the name that I put dun sa voltmeter. Ito yung nilagay ko sa current meter, ito yung nilagay ko sa voltmeter. So what you need actually is either. You can use either. Pwedeng scope data 1 or scope data lang. Okay, so itong gagamitin ko. And I click this again. Okay. And I click yung values. Okay, so ito na yung data. So X and Y. Now, how do you call yung data na yan? Okay, so ilalabas ko lang to dito. Lilipat ko lang to dito. Okay, so kung mapapansin niyo, meron ito out.scope_data1 and then open close parenthesis 1 and then values. Pag tinype ko yan actually, out.scope_data1 1.values. Okay, and i-type ko time. Okay, ang i-output niya ay itong time scale na nandito. Okay, so ang gagawin ko, i-assign ko yan as the time variable, so t. Okay, and then itong pangalawa, which is data lang. Kung makikita nyo, data lang siya. Okay, so gawin nating y equals. So papalitan ko to ngayon ng data. And then papalitan ko to ng y. Okay, so pag pinlot natin yan ngayon, t, y, you can see na yung result ay yung ating graph. Okay, so nandito. Okay, so that's how you generate yung, or that's how you generate yung data. Then you can just save that to text or save that to an Excel file or kung ano man ang gusto nyong gamitin. Okay, so andyan na siya. So yan yung pag-generate. Okay, so you don't actually need, later on, you don't actually need to go to click there and then open isa-isa. Yan na yung default actually na ginagamit ng Simscape. Okay, so you just actually pwede nyo nang diretsong copy-paste yan dun sa live script ninyo and then para makuha nyo yung data. Okay, so that's that for generating data. Okay, what else pagdating dun sa graph or figures? Of course, okay, meron kayo ng mga tools dito that you can use to zoom in, zoom out, and so on and so forth. Pero for zooming in and out, andito rin siya. Okay. Then, pwede nyo palitan yung itsura ng graph.
It's
Okay,
10 o'clock.
so layout, for example, kung gusto nyo double, ganyan. Kung halimbawa dual channel yung ginagamit ninyo. Okay, so dalawa. Yan, ganyan. So layout, balik natin sa isa. Okay, and then configuration properties. Okay, ito na yung kanina. Okay, and then yung style. Okay, ito yung itsura ng graph ninyo. Okay, so it's here. So figure color is currently white. So halimbawa gawin natin red para lang makita ninyo ang effect. And then gawin natin yan. Okay. So ganon, and then syempre papalitan natin yung kulay ngayon ng okay. Yan. Sinasadya kong saktan yung mga mata ninyo Okay, para lang makita niyo yung effect ng ginagawa natin dito. Okay? Okay, and then, of course, you will need to save the figure later. So, ang gagawin niyo is to file, paano na nga ito? Print preview or print to figure. Okay, so ganito yung mangyayari. Yan, ganyan yung gagawin ng MATLAB. Okay, and then you can simply save as JPEG or PNG or GIF, kung ano man yung kailangan niyo. Okay, so figure, yan, bitmap, and so on and so forth. So pwede nyo na i-save yan as figure. Okay, so yan. And then, what else? So, legend, kung gusto niyo maglagay ng legend. Okay, so nandiyan dyan. Okay, so, nandiyan lahat yan. Ready for use. Yung iba sa inyo, ginamit itong ruler na ito. So, this is actually a ruler which you can use to measure time scale. Okay, hintayin na natin lumabas. Okay. Okay. So, meron kayong bar dito and then another bar here. So, that bar here is 1. So, ito yun. So, this is where the first bar is positioned at 0.13 seconds. And yung second bar is positioned at 0.38. So, just simply move the bar kung saan nyo gustong ilagay. So, halimbawa, lagay natin sa, sige, lagay natin dito sa, yan. Oops. Okay. And then, lagay natin dun sa isang, sa second, tas, ano, sa 1 period. Yep. Okay. So, makikita nyo rito, okay, na nakalagay ngayon yung first bar sa 0.008361 seconds and then sa 25 milliseconds naman yung second bar. And makikita nyo na yung difference in time is 16.667 milliseconds, which is 1 period. Okay, by the way, nung nagdi-discuss kayo, yung iba sa inyo nagdi-discuss sa video, parating yung sinasabi na wavelength, at tignan natin yung isang wavelength. Well, actually, wavelength, you use wavelength if the x-axis scale, the horizontal scale, is in terms of distance. Pero here, it's in terms of time. So ang ginagamit nyo dito is period. So you're referring to one cycle as 1 period kung time scale yung nire-refer lang natin dito. Okay? So you can see na yung delta t is 16.67 milliseconds. Kino-compute niya kagad yung frequency, so it's 60 Hertz. And then kino-compute niya rin yung slope at this point. Okay? Or at this point. Yeah, at this point. So that's about 5.561 amplitude per megaseconds. Okay? So, yes, palitan lang natin, ibalik natin sa default values para hindi masakit sa mata. Okay. Of course, pwede rin kayo maglagay ng mga markers. So, pwede ko nang tanggalin yung marker din. Okay. Ay, hindi, ibalik natin yung marker. Kasi, meron akong gustong ipakita. Okay, now, sa settings, meron ditong snap to data. Okay? Pag kinlik ko yan, if I move yung marker, mapapansin nyo, okay, mapapansin nyo dito, okay, na hindi na siya pumupunta dun sa gitna. The marker immediately goes to the nearest, okay, data point. Okay? So tignan nyo mabuti. Move ko to sa left. Okay, diretso siya dun sa next data point, diretso sa next data point, and so on and so forth. So hindi nyo na pwedeng ilagay yung marker in between the data points. Okay, yan yung ginagawa ng snap to data. Okay, which is good kasi it doesn't make sense to refer to anything between the data points. Okay, so yan yung ginagawa ng cursor measurements. What about this one? This is ano na nga to, statistics. Okay. So signal statistics. Okay, so we have it here. So yung maximum value is 1.698 milliamperes in our case. And it occurs at 0.038 seconds, and ganun din dito. And then yung peak value ay ito, and so on and so forth. And you can see yung RMS value is 11.72 times 10 to the minus 2, which is about 12 or 12 milliamperes as expected. Okay, ito naman, bi-level measurements. Well, I'm not sure if you really need that. Okay, so and then ito naman ay yung peak finder. Okay, so medyo baka mas useful sa inyo yung peak finders. Tanggalin na natin itong bi-level measurements, and then yung peak finder ay dyan. So pag kinlik natin itong check mark, papakita niya sa inyo kung nasan yung peak, and dahil kinlik natin yung snap to data, dun siya didiretso dun sa data points. Okay? So yan yung features na meron dito sa graph. Okay? So next time you can, or in the next experiment, you can play around with this. Okay, para mas maging maayos yung presentation ninyo. Okay, and since of course gagawa kayo ng report dun sa next na experiment. Okay, so tips. Again, it's still a MATLAB software, so anything that you need, makikita niyo dun sa help function. And of course, marami available na resources sa internet. Okay, you can download your files from MATLAB to computer by doing the following. Okay, pinakita ko na sa inyo to, so hindi na natin ano ito. And then focus at one thing at a time. May isa sa inyo na nagsasaing pa. Okay, habang gumagawa ng trabaho, and syempre nakakakaba kasi kung nakalimutan niya yung sinaing niya, baka nasunog na yung sinaing or baka worse yung nangyari. Okay, so when you do your work, you try to focus on doing your work. Of course, maganda rin makita yan. These are funny moments na pagkukwentuhan nyo or natin after 10 years, kung makita-kita tayo ulit after 10 years. Okay, so I think that's it. Any questions? I hope na-solve ko na yung nasagot ko yung mga questions ninyo in relation especially din sa solvers. Any questions?
Sir, sa solver po, need pa
Yes.
po ba talaga naming mamili? May automatic naman po kasi option doon.
Pero ang point lang doon kaya ko kayo pinapapili is para makita nyo nga na para makita nyo yung mangyayari. Kasi ang mangyayari nga is ibibigyan naman kayo ng suggestions ng MATLAB. Okay, so in other words, gusto ko sana i-explore nyo, na-explore nyo yung mga iba-ibang options na yon. Okay, and also I was also expecting na hahanapin nyo rin yung mga solvers na yun sa internet kasi nandiyan lang naman siya available. Although well, sa napansin ko parang walang naghanap, talagang nag-trial and error lang kayo. No? So it's fine, okay lang yan. Okay, but remember na available yung resources sa internet. Okay? So dun sa future na experiments niyo, hindi niyo na kailangan gawin yan kasi ngayon alam niyo na. Alam niyo na kung ano yung solver na pipiliin niyo. So if you're not sure, go first with ODE45 and then MATLAB will suggest kung ano yung best na option. Okay? So any other questions? May iba pa kayong tanong?
Sir?
Yes, sige.
Yung report po for the next experiment, kailangan pa pong kasama sa recording or kahit hindi na po?
Sino yung nagsasalita? Si Crisel. Kailangan isama pa sa Anong report? Anong report ang ibig mong sabihin? Yung written?
Yes po, sir.
Hindi naman.
Sir,
May
group po
actually,
ba yun or individual?
hindi, group yun. Naka-assign kayo,
Okay
di
po.
ba naka-assign na kayo sa groups? So,
Yes, sir.
magsasubmit kayo in groups. So, isa lang sa inyong kailangan mag-submit.
Sir, kahit hindi na po kasama doon sa recording na isasend namin sa inyo yung kung paano namin
Hindi, hindi.
sasagutin yung...
Hindi niyo i-upload yung recording sa sa anong tawag dito? Sa VLE. Ganun pa rin yung i-share. So same procedures before. Yung tawag dito, Simscape circuit ninyo, i-share nyo sa isang MATLAB folder sa akin. Yung video, i-upload nyo sa Google Drive. And then yung answers to questions, yun yung i-upload nyo sa VLE. Okay?
Okay po, sir. Thank you po.
Yung iba sa inyo, dahil wala namang pinili nyo na hindi makipag-work with partners, yung folder ninyo, hindi ko na tinanggal dun sa MATLAB shared folder. Okay? Okay, so pakita ko lang. Pwede ka na siguro i-close yan. Okay, so kung titignan nyo rito, yan, kung titignan nyo rito, yung iba sa inyo meron ng sariling folder. Okay? Pero yung mga iba sa inyo na nag-share sa akin, lalo na yung mga nag-groups, wala na dito yung folder niyo dahil sinave ko na yan sa sa hard drive ko. Okay? So malamang makikita nyo na hindi naka-share sa akin yung So ganun ang gagawin ko. Since nagpapalit ng groupings yan, mag-share kayo ng panibagong folder sa akin every time. Okay? Dun sa mga nag-group. Pero ito para sa mga to, so si Jacqueline, Regine, Harvey, okay, dahil individual naman kayo, kahit na i-upload nyo na lang yung inyong dyan, yung inyong tawag dito, submission dyan. So hindi nyo na kailangan i-share sa akin every time yung folders niyo. Okay? So, any other questions? Nakita nyo na ba yung yung experiment number 2? Kahit mag-thumbs up lang kayo to say yes or no? O ayaw nyo pang makita? Nakita nyo na ba experiment number 2? Okay, so may mga iba sa inyo na nakita na. Okay, so the experiment number 2 is about the power supply. Okay, so maggagawa kayo ng power supply. The instructions ay straightforward. Okay, so nandiyan lahat. Ready na yung instructions dyan. Okay, so nandiyan na lahat ng instructions. So, yeah. So nandiyan na rin yung mga values na inano ko. Okay, and pati sa instructions doon sa questions, nandiyan na rin. Okay, so but kung meron pa rin mga confusion, tanungin niyo lang ako kung ano yung kailangan niyo malaman, and then sasagutin natin, and i-add ko dito sa instructions. Okay, so yung deadline is March 28. This is a Sunday. Class discussion on March 30. Again, this is scheduled na deadline to, no? Of course, pwede kayong mag-submit after the deadline, pero i-red flag yan ng VLE at sasabihin niya na late submitted. Okay? So, ganun yung mangyayari. Okay. Any more questions? Wala nang tanong. Ako naman magtatanong sa inyo kung merong gustong sumagot. I hope meron. How did you find yung experiment 1? in general? May mga anong masasabi niyo about Simscape, for example? Alam ko, wag na natin pag-usapan kung gaano kabagal. Nakita niyo rin naman na mabagal on my side. So, if you have any other comments regarding that, you can, pwede niyo i-share. Walang gusto mag-share? Nahihiya o wala talaga? Okay, sige. So kung wala kayong masabi, it's fine. Wala na rin akong ibang tawag dito, i-discuss for today. So I guess next time na makikita tayo ay sa March 30 na or anytime during consultations. Okay, so sige. Thank you for coming. See you next time.
Thank you, sir.
Thank you.